Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
As per my previous video tutorial 179, I did indicate that for now I'm gonna park the nighttime light series, whether it's the individual nighttime light series or the harmonized nighttime light series. I'm gonna park it for there. I did what I wanted to do, and I'm gonna focus now on something that I've been wanting to do for a long time. I've played around with it, but I thought let's do a series on it, a mini series on that. And I'm actually very excited to do this. It's a learning for me as well, and I hope it's gonna be also valuable and interesting to yourself. So to go on this little journey with me within the remote sensing journey, please subscribe. It costs you nothing, and we become a family. So it would be very, very nice if I can have you with me and you joining me for this ride. And let's go for it. So please remember, as I said, to like, subscribe, share, whatever buttons, press those buttons, and also Facebook page. Please feel free to join me on Facebook page as well. Then we'll go with this together. So with that said, let's get into it. So there's been quite an increase in land use, land classification tools and methods within QGIS. So although this is not a Google Earth Engine tutorial or series, obviously it relates to Google Earth Engine, because you can do some of this work in Earth Engine, and in fact we've done some of this work in Earth Engine, land use, land cover classification, etc., etc. I can't remember exactly when we've done it. It's a while ago, but the video tutorials are there how to do this in Earth Engine. But as I said, I'm going to play around with this in QGIS. So land use, land cover classification will be the theme of this mini series. How many video tutorials I'm going to do, I don't know, but it's going to be quite a number, because as I said, there's been quite an increase in these tools within Earth Engine. So let's go through some of them, or let's go through the ones that we're going to use during this series. We're going to start obviously with the big one, the big daddy, the semi-automatic classification plugin, and there it sits. So this is most probably the most complete, most comprehensive tool available for land use, land cover classification, and it is a plugin. I'll show you now the details of the plugin, but you get something like that. And we're going to go into it. The options, you have the band set options, you have download products, you have basic tools, pre-processing, band processing, post-processing, etc., etc. And there's your training window here where you train for the classification, etc., etc. So first and foremost, the one that we're going to use is the semi-automatic classification plugin. Now, I tend to use it a lot, not necessarily just for the classification purposes, but there's other very nice functions that you can use in. For example, functions that I use quite a bit is to reproject rasters, specifically when we want to reproject rasters into different output types. So if it's a float to integer or to byte or wherever the case might be, to reproject it. So that's a neat thing, a feature within the doc. So you can use this as well. So that's very interesting. And the other one that I'd like to use as well is also the vector to raster classification, because it gives you some options that some of the other options doesn't have. You can stack your raster bands, you can split your raster bands, you can do mosaicing, you can clip raster bands. There's a whole lot of things that you can do in the pre-processing, whether you do the classification or not, that's beside the point. There's a lot of neat functions you can apply here, and I use them in a lot of my work. And then also there's the band processing, whether you have the supervised classification, the unsupervised classification. You can do principal component analysis, you can see spectral density, and then obviously the nice part is also post processing. So we're going to spend a bit of time on this and run through some examples on this. Now, sorry, let me just say the purpose of this is to generate accent to generate land use, land cover classifications of my region of interest using all these different tools and different methods within these tools. And then let's compare them and see, okay, how does this one compare to that one? How does that method compare to this one? And let's see if we can sort of get an understanding of, in my region of interest anyway, a region of interest is which performs well, which doesn't perform well, etc., etc. Because as I said, there's a whole lot of them. Okay, so we're going to play around with the semi-automatic classification plugin to generate. And if you go to classification, they have different options. They have a minimum distance method, they have support vector machine, random forest, etc. So you see each of these, we're going to generate images. So this is different methods within this tool of generating land use, land cover classifications. And you see most of the tools that we have available uses these options as well. Most of them have random forest, most of them have minimum distance or k nearest distance, most of them have maximum likelihood, etc., etc. So yeah, we're going to play around with them, and within each of these tools there's obviously different parameters, and we can work on those different parameters as well. So basically we're going to create an inventory of these land use, land cover classifications per tool, per method, and within each method the different parameters. So that may lead us to 20, 30, 40 land use, land cover classification images, and then we're going to rate these images to see, okay, where does what fit in, which tools or which method seems to be more accurate or reliable versus those that's least or less accurate and reliable. So that's the purpose of it. Okay, so semi-automatic classification plugin. Okay, so there is it. It's like this little icon here, and it opens on the layers panel as well. And also on the bar here on top, it gives you SCP, standing for Semi-Automatic Classification Plugin. And there's all the details as well. So the plugin, there it is, and you can click on band processing. There's all the issues. So you can access it via its icon, via its thingamajig on the title bar, and on the layer here. This layer is specifically for the training. So this will be the training part here. Okay, so that's number one. Okay, so make a mental note. The semi-automatic classification, that's our number one option. Okay, SCP doc, I think it's the loose abbreviation of it, semi-automatic classification plugin. Okay, there it sits. Cool. Okay, so that's number one. Okay, so let's go to number two. So number two in my arsenal is this one here. It's called the Zetsaka classification. I don't know what, of whether my pronouncing is off the chart or correct. I don't know. Let me just close it here. Okay, it's called Zetsaka classification doc. Okay, so if I click on it, it opens a little window on the left hand side. Okay, it also sits in the raster. If I go to raster, it sits supposed to sit here. It's not sitting here, but it's supposed to sit here somewhere as well. Oh, sorry, under plugins, there it's at Zetsaka, and you go to classification doc. There's the settings, welcoming message, etc. So under plugin, Zetsaka is as well, so you can access it from under plugin or on its little icon, which is this what you call these things, magnifying glass. And then it opens up here. There, in this case, in the top part, you'll put your stacked or your virtual raster, the bands, all 7 or 12 or whatever bands. This is your training vector. and your ID of the training. And then you have your models. If you click on this little nut here, you'll have, again, you have your support vector machines. Okay, so you've got Gaussing mixture model, random forest, support vector, and k-nearest neighbor. So there's 4 methods within this plugin. 4 methods within this plugin, and they also have standard experimental, but I'm just leave it standard. So all these things you'll just use, leave as is. You can change the names and so on, select, but you just leave it. Nice thing is also you can generate the confidence map. You can save the model, save the matrix, etc., etc. Split, save the matrix where you want to save it, save the model, where you want to save it, mask, where you want to mask it, etc., etc. So, and then you basically just perform the classification. There's where you save your classification, or you load the model, etc., etc. So there's a nice little options there. Quite a neat little tool, very interesting tool, very informative, very nice to use. The big thing, obviously, is your data set, your images. And again, in both cases, in all cases, you can either decide to use either Landsat or Sentinel. Depending again what you want to do. If you're only looking at current, then Sentinel, I would suggest, is the better data set to use, purely because of its spatial resolution. If you're looking for historic picture, then I would suggest Landsat, but that's up to you. In our case, we're just going to use Sentinel because I'm interested in what currently looking like, not necessarily what it looked like in the past. So there's this specific tool. Okay, we're going to run through this tool in more detail, etc., etc. So there's the tool, quite straightforward, and I'll show you how to develop the training. So in this case, yeah, important to have a training file. Okay, so that is number 3. Number 2. Then number 3, okay, we have this little tool here, which is classification tool. Okay, and it's, let me open it. It looks like this. So the methods, random forest, k-nearest, support vector machine. So you'll start seeing that the methods are pretty much the same, or the very similar methods in all of these plugins, classification tools. The methods are very, very similar, but they have more, but they have less, etc. Again, your raster that you're going to add in your images and your training file and the training, and you're going to save it. And you get the options here to split it between the training and the testing data, and there's some options specific to the methods within the tool. Okay, so for example, k-nearest method. So if we select the k-nearest method, we'll go to k-nearest, and there's some options here: weights, distance, uniform, neighbors, auto, and you can choose here. So that's what I'm saying. Within each tool, there's different methods, and each method have different parameters. So that's why I say these things can add up, although it's debatable the difference using different parameters. But anyway, we're going to test that. It gives you a log. But as I said, I have issues with this tool that it doesn't always work. It's not normally one of my priority tools. Not because that it's not a good method, or it's just that for every reason I get lots of errors with this. I'll show you guys a bit later, or when we do this tool per se. Okay, so that's number 3, I think. Then number 4 is this one here, supervised classifier. That's number 4. Now, this is a fairly new one that came online, or according to me, it's a fairly new one. If you click on it, classification tool looks like that. Remember the icons. I don't think it's in plugins. Let me have a look and see. No, it doesn't sit here in the plugin, so it is only the icon. Let's say raster. It's not going to sit under raster. If we go plugin, classification, nope. So this is the only place you can find it is the actual icon. Okay, so just make a memory of that icon. Okay, so that's number 3. Supervised classification, then it sits. That's how its icon looks like. If I left click on it, then pass manager, input image, which is my stacked, my virtual raster, my reference shapefile, that's my training file. That's where I'm going to save it, and this is the variable within my training file, training shape file that I'm going to work with. Classification, let's have a look and see. Minimum distance, random forest, support vector, k nearest, and maximum. Like it says, not working. So I presume it's k nearest neighbors, support vector machine, random forest, and minimum distance. So 1, 2, 3, 4. So you'll see most of them have 4. Most tools, classification tools, have 4 methods, and you'll see most of the methods are the same things, and then you classify. Okay, so that's called the supervisor classifier. Okay, that's so let's open it there. There's another one there for unsupervised, so that's when you let the computer does everything. That's how it looks like. Okay, so then it sets supervised classification. So that's number 4. So number 5 is if we go into our process toolbar, we get to our neural networks. We get to neural networks. So that is my number 5. Okay, so if we click on that, now the SCP doc, that's sort of a self-contained, works on its own ins and outs. So that has its own processes, its own files, etc., etc. Number 2, 3, and 4, folks, the Zsaka classification tool and this supervised classification are very, very similar in they require the same documents. So if you have the information for the one, you'll automatically have it for the others. So number 2, 3, and 4 are very similar. The SCPT doc, that's very different. And then neural networks is also very different. So if I go to neural networks, I click on that. Neural network MLP classifier, click on that. You'll see it's supposed to open like that. There's your image. Again, your stack or your virtual raster. There's your training image, your training file. Now, in the previous ones, your Jetsaka classification and supervisor, your training image is in a vector file. Okay. Here they want the training image in a raster file. Now, this has given me lots and lots of grain hair because the image files, your stack raster, your virtual raster, must have exactly the same extent as the training image. If it doesn't have the same extent, i.e. width, height, and all these things, it will bomb out. It will not work. So we'll spend some time to show you how do we get these two files to have the same extent. And typically you're going to have to change your, when you do the conversion from the vector to the raster from your training image or your training file to a training image, this is where we're going to make sure that the associated training image has exactly the same extent as your image. Otherwise, the thing will bomb out. And then there's a whole lot of information down here where we're going to work with number of neurons, maximum number of iterations, test size. That's how many in your prediction versus your testing, and then your activity functions and stuff. Yeah, there's your activity functions. Okay, so we're going to work for logistic, identity, and only some of them work. Okay, only some of them are relevant. Not all of them are relevant. So there's your neuron network classifier. Again, very interesting, very useful, very nice to work with, and something that I think has lots of potential. Anyway, don't want to be biased, so my bias is before the time. Just bear that in mind. So that is number 4. Okay, so up to number 5. Up to number 5, we've worked with pixel-based image classification. Okay, so the value of the surface reflectance, that's what we're working with. Okay, so we're working with the surface reflectance to generate this classification. but we can also work with object based classification. So we're going to do both. Okay, so we're going to do image based classification, land use, land cover classification. We can also look at object based. And the object based, we're going to look at the white box tools. Okay, so that will work in the white box tools. We go into the white box tools, you'll see there is machine learning, there's image processing classification. So you'll see there's some, we're not going to work with that. We're going to work with the machine learning, if I'm vaguely correct. And there is a random forest classification. Random forest, yeah, and the supply vector classification, KNN classification. And in this case, yeah, we'll keep that. That's where we work with object-based classifications, which we'll also do. So I'm just going to say number 6, and there's a number, and also some of them is raster-based, but in this case also, first time that we're going to work with vectors. To classify vectors, because up to now all the classifications are based on rasters. In some of these cases it's going to be based on vectors. So white box also has a lot of classification tools that we're going to work with. Okay, and I think that is it. That is the ones that we're going to work with. So there's 6 tools that we're going to work with. So where would you get these tools? You get them all under plugins. So you can go plugins, manage and install plugins. And I'm just going to go installed. You'll see there's the classification tool. So there is its homepage. So let me click open that homepage. So there's a classification tool. Prerequisites, please make sure you go through this. Prerequisites, install that Python packages. Okay, and you can install it directly into. You can install these packages directly in QGIS. So, for example, okay, you just basically just pip install pandas. You just copy this. Okay, so you copy this. I'm not going to do it. I don't want to create classes. So you just copy that, close. Then you're going to go into plugins. You're going to open Python. And here, you just do the explanation mark, and then you paste it in. And then you press enter, and then it will install. Okay. So remember to add this exclamation mark. In Python itself, you don't have to do it, but within the Python console in QGIS, use your explanation mark. Okay, then you'll install it. So always follow up on the where is it now? Always follow up within the landing page of these plugins. Okay, so let's quickly open it again. So there's my classification. There's my home page. Let's open it. There's my home page. There's all the codes for it. The getting started, prerequisites, installation, etc., etc. Okay, so there it sits. I don't think it's a very stable tool, but anyway, that's a classification. I'm just going to go alphabetically. There's the ZSACA classification tool. There it sits. Again, look at the home page. There is the home page of that specific one. Again, make sure that these Python packages are installed. If you installed it, you should be fine. So there it sits. It's got there's some YouTube videos how to use it. It's got a manual how to use it, etc., etc. So it's much more user friendly than the previous one. So that is the Zaka. Then we have the neural network classifier. There it sits. So if we go home page there's a neural network classifier. There's installation instructions. And I think it's also some packages. Yep. some packages that you need to make sure that you have installed within within your QGIS environment. And then so that's your neural one, and so that's yeah. Then we got so that's your neural one. And then we've got our supervised classification. There's our semi-automatic classification. There's its homepage, and there's also a Facebook page, etc., for this one. But there it sits. There's semi-automatic classification. Luca, the brainchild after this, behind this. And there's my supervisor classification. There it sits. So that's all the ints. You'll see again, they all require roughly the same. They all roughly require the same R packages to be installed. There its details are. And the last one is the white box for QGIS. There it sits. There is it landing page where you can have a look at it. To see. So that's essentially where they all are. They all are in plugins. Just go and search for them and install it within your QGIS. And then within your Python environment, make sure that those Python packages are installed. To know what Python packages go to the home page of each of these tools, and within the home page it'll tell you which Python packages. Then you can either install your Python packages through Python itself on your computer, or you can just use QGIS within the QGIS Python environment. And just remember to put the exclamation mark before you say pip install, etc., etc. So there they are, all of them, all 6 of them. The SCP doc, semi-automatic classification plugin, there it is. Tetsaka, there it sits. That's the one there. Classification tool number 3. Supervised classifier number 4. Neural network number 5. And white box machine learning number 6. So there's all 6 methods that we're going to work with. And I said we're going to do both image classification based on the images, on the spectral signatures, meaning the signatures that each pixel cell has in terms of the bands. But we're also going to do object-based classification, where we see that urban. We will get to it. We're not going to go into the details because it's too much to quickly just go through them. So obviously, before we continue, okay. So please make sure you've downloaded and installed these plugins. And please make sure that you've installed the associated Python packages. Once you've installed the plugins, once you've installed the Python packages, we should be ready to go. So then you have your tools, your plugins ready to be used. And the first thing that obviously we have to do is we have to either decide to use Sentinel, or we're going to use Landsat. Now, I said in my case, I'm going to use Sentinel. So the next step obviously is to prepare your data, to prepare your images. So we've got our plugins, we've got our tools. Our tools are installed, the associated packages are installed, Python packages. We understand the tools. We understand roughly what we need for each of these tools, and in general for all of them we need the daytime images, and we need the associated training images or training files. So those are the 2 things that we need. So the next video tutorial will be on how do we get our images and our data set up. How do we get that ready to be used? Tools on the one hand, and images and data set on the other hand. We need to bring these two together. We generate the classifications, and then we're going to do the comparison. Okay, so stick with me. I can't make you famous, sadly. Um, what's that saying? Stick with me, I'll make you famous. I can't make you famous, but I can hopefully, help you to get some interest, get some valuable knowledge and experience on working with image classification. Um, at least, if not that, to get you interested in this. Yeah, so this is something that I wanted to do a while ago, and I'm happy that eventually it's time for me to focus on this. How many videos, how long it's going to take, I don't know, because there's a lot to do. Some are repetitive, some are new. Problems also, these programs are not very stable. They all have finicky, they all have ins and outs. So hopefully we don't have major issues within each of these plugins, tools that we can use. Nonetheless, that's in a nutshell what we're going to do. Okay, so stick with me, and please subscribe. Let's do this together. Join me. I welcome you, and I'll see you on the other side.